Good evening everyone, good evening. I welcome you all again to the NEET Elite. Hoping that you guys are doing great, having the good time. Well people, you can let me know in the chat box if I'm audible and visible to everyone. Let me know in the chat box with some thumbs ups, yeah? Thank you Rohini, thank you. Perfect. Wonderful, I'm doing great. I'm doing great guys, I'm doing great. Just let me know in the chat box if I'm audible and visible to everyone properly, yeah? Perfecto. Well, Yashwant has come up with a quote after so long. Mornings are so stressful, afternoons are so lackluster in mind. Bro, it just went up. I couldn't read it properly. Okay. So people, let me know in the chat box. Give me some green signal from the chat box so that I'll get to know whether I'm audible and visible to everyone or not. Let me know in the chat box. Let me know in the chat box. I'm doing great, Ankita. I'm doing great. How are you? Welcome back. Welcome back. Welcome back. Welcome back. Welcome back. Perfect. Perfect, guys. So as you all must be knowing, today we are going to do the GOC part second, which you call as isomerism. Yeah. And in the today's session, we are going to do, this is going to be a first lecture from the topic isomerism, right? I'll be exactly starting from the basics. Okay, what are isomers? How do we classify these isomers? Everything will be done in detail, right? And let me just give you the overview of what all things we have to discuss in the today's session. Well, in the today's session, we'll be talking about something called as structural isomers, yeah? And its few types, okay? We are going to talk about the chain isomers. Okay, we are going to talk about the functional isomers, position isomers. These are the three different types of isomers which I'm going to let you know in the tonight's discussion. Yeah, and people, at the same time, I'm simply going to give you some tricks by means of which you can clearly identify the position and the chain isomers as well. Yeah, perfect. Right. Yes, Aditi, we are done with chemical bonding. Yes, yes, yes. Alkenes, we are not done yet. Alkenes, we are going to do in the hydrocarbon session, yeah? Okay. So, before starting the session, for the ones who are new to the channel, let me introduce myself. My name is Wassim Sir and I'm your chemistry master teacher right here. Okay. For the ones who have not liked the video yet, please do like the video, share the video with your friends, subscribe to the channel, and do not forget to hit the bell icon so that you get the notification of every single session which I'll be taking right here on this NEET Elite channel, yeah? Perfect. Kit to gaming zone. Sir, when are we going to do hydrocarbons? Well, I've already taken 5 or 6 sessions from the chapter hydrocarbons. You can watch those. Yeah. Next session, maybe, that's going to be maybe day after tomorrow. Yeah. Perfect. So people, let me know in the chat box if you guys are super duper excited about the session. Yes, let me know in the chat box if you guys are super duper excited about the session. Let me know with some thumbs ups, yeah? Let me know in the chat box. Perfect, guys, perfect. All right, so without wasting a lot of time, so I can see the Josh is high, yeah? Perfect, guys. So without wasting a lot of time, let's get started with the topic isomerism, okay? First of all, you would have studied in class 10th as well, right? In class 10th, we studied these isomers, correct? Okay. As per the basic definition of isomer is concerned, isomers, these are basically the molecules which have got the same molecular formula, but their properties will be different. And these properties can be either physical or chemical, right? Simple way by means of which we define the isomer. Isomers are the molecules which have got the same molecular formula but different properties. Properties can be either physical or chemical, right? So in short, the molecules which are going to have same molecular formula but different either physical property or chemical property, that's what we call as the isomers, right? Okay. For example, let me give you the clear-cut example of the isomers over here, okay? Understand properly what I'm going to say. See guys, look here. Over here, you can see I've taken 2 structures right here, yeah? Okay, just have a look. This is CH3C double bond OH, yeah? That means this is the carboxylic acid which I have right here. Correct? This is the carboxylic acid. right? Because you have got COOH group attached with it. Yes. And over here, which group is this? This is the ester group. Yeah. This is something which we call as ester. Correct? Well, we will just look at them carefully. Look at them carefully. This is CH3C double bond OH. This is CH3OC double bond OH. Correct? Well, look at them carefully. Can I say something like this? These two molecules, they have got same molecular formula, right? Molecular formula of this carboxylic acid right here is C2H4O2. The molecular formula of this ester right here is again C2H4O2, correct? So these are the molecules which have got same molecular formula. But this is carboxylic acid, this is ester. That means their chemical properties will be different, absolutely, right? And whenever I'll be having the molecules with the same molecular formula, but different physical or chemical properties, we call those molecules as isomers, yeah? Can I say these two are basically isomers of each other? Yeah, absolutely, these two are the isomers of each other, correct? Because they have got same molecular formula, but different chemical properties. Why their chemical properties are different? Because the functional group which is attached right here is the carboxylic acid, and the functional group which is attached right here is the ester, right? Okay, that's why their chemical properties will be different. As simple as that, correct? So I'm sure you're clear with the basic definition of what isomers are. Isomers are the molecules which have got same molecular formula, but their chemical or physical properties will be different, yeah? Moving on. Now people, basically we have to do the types of isomers right here, okay? We are going to talk about the types of isomers, correct? Okay, and people, let me tell you, isomers we classify into two types. One is called as structural isomers, which is also called as constitutional isomers, right? And the another one is what we call as stereoisomers, which is also called as configurational isomers, yeah? So we have got two different types of isomers, broadly speaking. One is called your structural isomer, one will be stereoisomers, right? So you have got, broadly speaking, two types of isomers. One is your structural isomers, another one is your stereoisomers, right? Now, let's talk about this structural isomer in detail right here, okay? And in the next session, we'll be talking about the stereoisomers, okay? So first of all, let's get to know what these structural isomers are all about, yeah? Well, people, as per the definition of structural isomers is concerned, structural isomers are the molecules with the same molecular formula, but their structural formula will be different, okay? So, structural isomers, these are the molecules with the same molecular formula, but different structural formula. What do we mean by that? What all things can we understand from this statement? Understand properly what I'll be saying right here. Okay, first of all, remember the definition. Structural isomers are the molecules which have got same molecular formula but different structural formula. See guys what I'm talking about. Just give me a second. Yeah? Okay, look here now. Look here. People, have a look on these two molecules which I've taken over here. Yeah? This is CH2, this is double bond CCl2, right? This is again CHCl, this is CHCl again, yeah? So first of all, can I say the molecular formula of these two molecules is same, right? The molecular formula of the first one is CH2, CCl2, right? The molecular formula of the second one is same, it's going to be again what? It's going to be CH2, C2Cl2, right? Yeah? I can say these two molecules, they have got the same molecular formula which I've written over here, C2H2Cl2 in short, correct? Right? I can say something like this. So these two molecules, they have got same molecular formula first of all, correct? This is one of the proposed structure of this molecule whose molecular formula is this one. This is one more proposed structure of the molecule whose molecular formula is this one, right? So I have basically two structures right here. If I ask you, what is the structural formula of this compound? What is the structural formula of this one? It's simply going to be CH2 double bond CCl2, correct? This is the structural formula of this molecule, right? What about the structural formula of this molecule? The structural formula of this molecule is going to be simple, CHCl double bond CHCl, correct? So we will just have a look on these structural formulae over here. Are these structural formulas same or different? Well, you can clearly have a look. The structural formulas are different. This is CH2 double bond CCl2. This is CHCl double bond CHCl, correct? Yeah. So can I say something like this? These are the two molecules which have got same molecular formula, but their structural formula is different, right? And whenever I'll be having such kind of molecules which will be having same molecular formula but different structural formulas, we call those molecules as the structural isomers, yeah? So basically, these two molecules are structural isomers of each other. Let me know in the chat box if you got the concept of what these structural isomers are. Then I'll be talking about these isomers in detail. Yeah? Let me know in the chat box. With some thumbs ups, yeah? So whenever I'll be having such kind of molecules which will be having same molecular formula but their structural formula will be different, we call those molecules simply as the structural isomers, yeah? So these two are the structural isomers of each other, correct? Wonderful. Let's move on. I'm not going into detail right now. In detail, we'll be getting in after some time, yeah? Okay, right. The next category of these isomers are what we call as stereoisomers. Now, what are stereoisomers all about, right? Remember the definition first, then only you can get the clear-cut idea of what these stereoisomers are all about. Let me tell you, stereoisomers, these are the molecules having same molecular formula first of all, having same structural formula, but different arrangement of atoms in 3D. Okay, as you can see right here, these are the molecules with same molecular formula and the structural formula, but different arrangement of atoms in 3D. Okay, what were your structural isomers all about? Structural isomers were the ones which will be having same molecular formula but different structural formula, right? But over here, stereoisomers, these are the ones which will be having same molecular formula, same structural formula, but different arrangement of atoms in 3D. Now the point is, how can we understand this? How can we get this definition of stereoisomers over here, right? See guys, I have got a molecule whose molecular formula is C2H2Cl2, right? Okay, this is the molecule which I have, C2H2Cl2. Now first of all, I'm going to propose some structures of this molecule, okay? Let me make two random structures of this molecule. See, this is the first structure which I'm drawing for this molecule. This is the second structure which I draw from this molecule, yeah? Correct? Now we will understand properly. See guys, first of all, these are basically two different structures of this molecule whose molecular formula is C2H2Cl2, yeah? Now first of all, if I ask you, what is the structural formula of both these? What you will clearly say, you will say structural formula of the first one is CHCl, and in between you have got a double bond. From right side you have got again CHCl, correct? If I ask you, what is the structural formula of this one? It is again going to be CHCl, right? It's again going to be CHCl. Then we have got double bond in between. On the right side, again you have got CHCl, correct? Well, people, have a look properly. These are the two different proposed structures of this molecule, correct? And these are the structural formulas, right? These are the structural formulas. Well, if I ask you, are these structural formulas same or different? These are same, right? These two structural formulas are same. So first of all, these are the molecules which have got same molecular formula, and at the same time, they have got same structural formula as well. But we will understand. See, if you talk about this carbon, on the top you have got hydrogen. If you talk about this carbon, on the top you have got chlorine, right? On the bottom you have got chlorine, on the bottom you have got hydrogen. Can I say these are the molecules which have got same molecular formula, same structural formula, but different arrangement of atoms in 3D? Yes, and we call these two as the stereoisomers of each other. I'll be calling them as the stereoisomers, yeah? Correct? So whenever I'll be having molecules which will be having same molecular formula, same structural formula, but different arrangement of atoms in 3D, those molecules are what we call as stereoisomers, yeah? This is just the broadly I'm classifying them. Broadly I'm telling you all this, okay? Exactly, Captain America, just the rearrangement happened over here, right? That's it. Let me know in the chat box if it is clear till now. Let me know fast so that I can move on. Yeah? So they have same structural formula. So they are stereoisomers of each other, correct? Now the point is, the classification of structural isomers, right? Classification of structural isomers, which is very important, right? The first type of structural isomer, which I'll be talking about right here, that's what we call as chain isomer. Chain isomer is the first type of the structural isomer, okay? So what are these chain isomers? Very simple, guys, very simple. Understand properly, okay? What are these chain isomers? First of all, chain isomer is the type of the structural isomer, yeah? It is the first type of structural isomer over here, correct? Now the point is, what are these chain isomers? For the molecules to be called as chain isomers, for the molecules to be called as the chain isomers, the molecules should have same molecular formula, number one. They should have same functional group attached with the parent chain, right? And the third one, the parent chain should be different. I'll be calling two molecules as the chain isomers. Number one, if they will be having same molecular formula, if they'll be having same functional group, if their parent chain will be different, yeah? For example, understand. This is the molecule which I'm taking whose molecular formula is C5H10O2, correct? Now I'm going to propose few structures for this molecule whose formula is this one, yeah? Okay, understand properly what I'm going to say. I've taken the molecule as C5H10O2, correct? Now people understand. These are the two different structures which I have proposed for this molecule whose molecular formula is C5H10O2. Now understand. Should I be calling these two molecules, as chain isomers? I can call them as the chain isomers if these two molecules are satisfying these three conditions over here. Yeah, then only I'll be calling them as the chain isomers. What are the conditions? Number one, they should have the same molecular formula. Absolutely both the ones have got same molecular formula. Check it out. How many carbons in the first one? 1, 2, 3, 4, 5. So it's basically C5, and when you'll calculate the hydrogen, it'll be H10 and O2. Similarly, this one is going to be C5H10O2 as well. So first of all, these two molecules, they have got same molecular formula. Number one. Do we have same functional groups in both these structures right here? Yes, we have got same functional groups. This is carboxylic acid, this is carboxylic acid. Functional groups are also same, right? Functional groups are also same. People, do we have different parent chain in these molecules? Yes, we have different parent chain as well. See guys, the parent chain in the first one is this one. This is the parent chain in the first structure, and this is the parent chain in the second structure. In the first chain, how many carbon atoms are there in the parent chain? 1, 2, 3, 4, 5, right? How many over here? 1, 2, 3, and 4, right? So people, is the parent chain same or different? Parent chain is different, right? And people, whenever I'll be having the molecules which will be satisfying these conditions, number one, they'll be having same molecular formula, same functional group, but the parent chain will be different. We call these molecules as the chain isomers in short. Yeah? So these two molecules, these are basically chain isomers of each other, right? Right? Let me know in the chat box. Let me know in the chat box fast so that I can move on. Let me know in the chat box. Perfect. Wonderful. Santosh, this is going to take some time, okay? This is something which is interesting, okay? And this is something which I'll be teaching in detail, okay? Right? This is going to take some time. Perfect, guys. Let me take one more example. Of the chain isomers. Understand. I've got the molecule whose molecular formula is C4H10O, right? I've taken a molecule whose molecular formula is C4H10O, correct? Right? I've got the molecule whose molecular formula is C4H10O. Now I'm going to propose two structures of the molecule whose formula is C4H10O. This is first proposed structure. This is second proposed structure of the molecule whose molecular formula is this one, right? First of all, are these two molecules having same molecular formula? Check it out. Yes, they have got same molecular formula. Both the ones have got C4H10O as the molecular formula. Number one. Number two, do we have the same functional groups? Yes, we have got the same functional groups, right? Do we have the different parent chain right here? You can check it out. This is the parent chain in the first one, and this is the parent chain in the second one. Are the parent chains same or different? These are different, right? So we have got 4 carbon atoms in the parent chain right here. We have got 3 carbon atoms in the parent chain right here. So basically the parent chain is different, and when the parent chain is also different, same functional groups, same molecular formula. So these two are basically the chain isomers of each other. Yeah, I'm sure it's clear to you, right? I'm sure it's clear to you, correct? Now people understand. There is something called as position isomers as well, okay? In few minutes, I'll be letting you know how to identify the position and chain isomers, okay? First of all, understand the basic things, right? What are position isomers all about? I can call two molecules as position isomers only if they follow certain conditions. I can call two molecules as position isomers only if they follow two conditions. And what are those conditions? Number one, the molecules they must have same molecular formula, number one. They should have same functional group, right? Their parent chain must be same, but there should be difference in double bond, triple bond, substituents or functional groups, right? There should be difference in the positions of double bond, triple bond, substituents or functional groups in the carbon chain, in the parent chain, yeah? Okay, so remember this thing first of all, then only you can understand all this. So first of all, I'll be calling two molecules as position isomers only if they follow certain conditions. What are the conditions? Number one, molecular formula must be same. Number two, functional group must be same in both of them. Number three, parent chain in both the molecules should be same. Number four, the position of double bond, triple bond or substituent or functional group, that should be different. That should be different. Then only I can call them as the position isomers, yeah? Right? Now understand what is that. Understand what is that. Look here, guys. Look at these molecules properly. Look at these molecules properly. First of all, if I ask you, do these molecules have the same molecular formula? If you'll check it out, they will be having same molecular formula. They'll be having same molecular formula, right? Number one. Number two, is there the same functional groups attached in both the molecules? Yes, there's the same functional group. Alcohol, alcohol, OH, OH, right? Okay. So first criteria is satisfied, second criteria is satisfied, third criteria. Is the parent chain same or different? Parent chain, right here, this is the parent chain in the first one and this is the parent chain in the second one, correct? The parent chain of the first molecule contains 4 carbon atoms. Parent chain of the second molecule also contains 4 carbon atoms, right? So parent chain is again same. So this condition is also satisfied. Now check the position of the functional groups right here. If I give numbering to this carbon chain, to this parent carbon chain, it should be 1, 2, 3, 4. So at carbon number 2, we have got OH group attached. Yes. Over here, 1, 2, 3, 4. At carbon number 1, OH group is attached, correct? So is the position of functional group same or different? There is difference in the position of the functional group, yes. So whenever I'll be having two molecules which have got same molecular formula, same functional groups, same parent chain, but difference in the position of either pi bond, triple bond, substituent or functional group, we call them as the position isomers, right? So these two isomers, these are basically position isomers of each other, right? Right? Perfect, guys. Exactly. Exactly. Moving on. These are position isomers of each other. Now the point is how to identify which isomers are chain isomers and which isomers are position isomers, right? That's important. You need to identify the position. How do we identify the position isomers and chain isomers? There is some simple trick which you guys are going to remember in order to check the chain isomers and position isomers. What is that trick? Just give me a second. For the ones who have not liked the video yet, subscribe to the channel yet, do subscribe to the channel. Do not forget to hit the bell icon so that you get the notification of every single session over here. Yeah? Perfect, guys. Now, what I was telling right here is, in order to check the position and chain isomers, I'm defining a number over here. Okay? Okay, I'm going to define a number AB. Understand what I'm going to say, okay? A stands for, first of all, this number AB, it can be, for example, 60, it can be 65, it can be 73, it can be anything, 71, 84, it can be 90, anything, okay? Where A is the first number, B is the second number. A is the first number, B is the second number, right? So basically, I'm going to define a number AB, yeah? I'm going to define a number AB, where A is the number of carbon atoms present in the parent chain. A is basically the number of carbon atoms present in the parent chain. And what is B? B is the substituents starting with carbon. B is the substituents which are attached to the parent chain which starts from the carbon. Understand what I'm going to tell you, okay? I'm going to define a number, AB, where A stands for number of carbon atoms in the parent chain, number 1, and B stands for the substituents starting with carbon atom. Substituents starting with C, okay? Now people, once I get the number AB, once I get the number AB, I'll be letting you know its examples in some time. First understand, once I get the number AB, if AB number for the two molecules, if the AB number for the two isomers will be same, we call those isomers as position isomers. If the value of AB, if the number AB for two isomers comes out to be same, we call those isomers as position isomers, right? And if the number AB is different for the two isomers, we call them as the chain isomers. So remember this in short. If the number AB, which I'm going to define, okay, if the number AB for the two isomers comes out to be same, we call the isomers as position isomers. If the number AB for the two isomers comes out to be different, we call them as the chain isomers, right? Let me give you certain examples. Let me give you certain examples so that you get the clear-cut idea of all this, yeah? Right? Shrishti, you can just refresh your page once, because on my side connectivity is all okay. Yeah? So we will understand what I'm going to do. What is A over here? A is the number of carbon atoms present in the parent chain, right? B is the substituents starting with carbon. Understand how I'm going to apply this. See guys, these are the two isomers. First of all, I'm telling you from here only, these are the two isomers. They have got same molecular formula and everything, okay? Right? Now I need to check, are these basically chain isomers or position isomers? How do I check that? How do I check that? Few minutes back I told you, I'll be defining a number, right? What is the value of AB? What is the value of number AB for the first molecule? Check it out. A stands for the number of carbon atoms in the parent chain. This is your parent chain over here. And how many carbon atoms do we have? 1, 2, 3, 4. So the value of A for the first molecule is 4, correct? B stands for the number of substituents starting with carbon. Towards this parent chain, we have got one substituent, right? But is this starting with carbon? Is this parent chain starting with carbon? No. I mean, is the substituent starting with carbon? No. So B value over here is 0. So AB value for the first isomer is 40. Yeah? Let's calculate the AB value for the second isomer as well. Understand? First of all, check the parent chain. Check the parent chain. Which one is your parent chain over here? Which one is your parent chain? Understand? Can I say this is my parent chain? Yes, this is my parent chain, right? How many carbon atoms do we have right here? 1, 2, 3. 3 carbon atoms in the parent chain. So A value for this is 3, right? How many substituents are attached with this parent chain? We have got 2 substituents, but out of these 2 substituents, only one substituent starts with carbon. So 31 is the value of AB over here. So is the value of AB same or different? The value of AB is different. And whenever the value of AB comes out to be different for 2 isomers, we call them as chain isomers, right? Right? We call them as the chain isomers. So simply these are chain isomers of each other, correct? I'm sure it's clear to everyone, right? Simple. Get the value of AB. If the value of AB comes out to be same for the isomers, then those are going to be position isomers. If the value of AB for the isomers comes out to be different, they are going to be your chain isomers, yeah? Right? Let me take one more example. So the value of AB over here comes out to be 40. The value of number AB comes out to be 31. So these are basically chain isomers, yeah? Now, let's take this example as well. You can clearly tell me, are these chain isomers or position isomers? Clearly, just get the number AB. That's it, right? So first of all, get the parent chain. This is the parent chain right here. How many carbon atoms in the parent chain? 4 carbon atoms, right? Now, people, how many substituents we have? 1. But is the substituent starting with carbon? No. So 0. So AB value for the first molecule is 40. What about the second one? Get the parent chain over here. This is the parent chain, yeah? How many carbon atoms in the parent chain? 1, 2, 3, 4. 4 carbon atoms in the parent chain, right? Now, people, how many substituents do we have? 1 substituent. But is the substituent starting with carbon? No. So 0. AB value for both these isomers comes out to be same. And when the AB value for both the isomers comes out to be same, we call these isomers as position isomers, right? Let me know in the chat box if you got the idea of how to check the chain and position isomers, yeah? If you got it, do not forget to like the video. Yeah? Right. Let me know in the chat box if it's clear. Let me know fast so that I can give you some nice examples. Okay, let's get started and let's try to solve certain questions by means of which you can get it properly, okay? And this is our main topic of tonight's discussion, how to identify chain and position isomers. This is very, very important, okay? Very important. Just follow this simple trick, you can easily solve all the questions, right? Okay, so people understand. First and second, chain or position. How do I check? First of all, get the number of carbon atoms in the parent chain. 1, 2, 3, 4, 5, 6. The number of carbon atoms in the parent chain right here is 6. How many substituents do we have? We have got only one substituent, which is CH3, which is starting from carbon. So the value of AB over here is 61. What about this one? What about this one? This is 1, 2, 3, 4, 5, 6. The value of A is 6. How many substituents? One substituent, and this substituent starts with carbon. So 61 is the value of AB, right? So AB value over here is 61. Over here again is 61. So AB value is coming out to be same. So these two isomers are basically position isomers of each other, right? These are position isomers, correct? Yeah. Moving on to the second one. See, get the number of get the number of carbon atoms in the parent chain. 1, 2, 3, 4, 5, right? Over here, 1, 2, 3, 4, and 5, correct? Right? So what is the value of AB for this? It's going to be 51. Over here, it's going to be 51. So should I be calling them as the position isomers? See, look here, guys. The number of carbon atoms in the parent chain is 5. Okay, there is one substituent, that too is starting from carbon. So 51 is the value of AB. Similarly, 51 is the value of AB. So should I be calling them as the position isomers? No way. These are identical ones. This is 2-methylpentane. This is again 2-methylpentane. So these are not isomers. These are identical. It is just I have reversed this. This one I have reversed. That's it. These are not position isomers. These are identical. Okay. Correct? Yeah, I'm sure it's clear to everyone. Let's talk about this one. First of all, give the numbering in the parent chain 1, 2, 3, 4, 5, and 6, right? So the value of how many carbon atoms do we have in the parent chain? 6. How many substituents are there? There are 2 substituents, CH3, and both the substituents are starting from carbon. So 62 is the value of AB for this molecule. What about this one? It's going to be 61. There is only one substituent over here, right, which starts from the carbon. So 61 and 62. So AB value is coming out to be different. And when the AB value comes out to be different, the isomers are going to be definitely what? Chain isomers. Got it? Right? Let me know in the chat box if it's clear to you. Exactly. Wonderful. Moving on to a few more examples. Okay, these are few more examples. You can easily kill them up. Okay? You can easily kill them up. Right? So first of all, if I ask you what is the value of AB right here, so there are 6 carbon atoms in the parent chain, number 1, okay, there is no substituent, so 0. So it's again going to be 60, right? So first of all, are these going to be chain isomers or position isomers? The value of AB comes out to be same for both the one, right? So these are going to be what? Position isomers. Yeah. Now get the value of AB for these two, right? So in your parent chain, you have got 6 carbon atoms, right? And you have got 2 substituents, and both the substituents starting from the carbon, right? So the value of AB for this one is 62. Similarly, 6 carbon atoms in the parent chain and 2 substituents, and both the substituents starting with carbon. So it's 62 again. The value of AB for both the molecules comes out to be same. So which isomers these are going to be? These are going to be position isomers. As simple as that, right? Okay. Exactly. Now people, this is the bicyclo compound, right? It's a bicyclo compound. And how do we do numbering for the bicyclo compound, right? We always start from the bridge. I hope you remember, class 11th mein padha hoga aapne. You would have studied this in class 11th, right? We always start from the bridge, right? So for example, this carbon number 1, 2, 3, 4, 5, 6, 7, 8, right? So how many carbon atoms in the parent chain? There are 8 carbon atoms in the parent chain. How many substituents do we have? We have got 2 substituents. This is basically your CH3. This again your CH3. Are these 2 substituents starting with carbon? Yes. So it's going to be 2 over here. So 82 is the value of AB. What about the value of AB for this one? Start again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so 10 carbon atoms. 10 carbon atoms in the parent chain, right? Apart from that, is there any substituent? No. So the value of AB right here is 100. Is the value of AB coming out to be same or different? The value of AB is coming out to be different. So these are again going to be what? These are going to be what? Chain isomers, because the value of AB comes out to be different, right? Nageshwari, I'll be doing the hydrocarbons. Next week we'll be finishing that, okay? That's no exception at all. No exception at all, right? Perfect. Perfect. Now we will see, understand. So first of all, let's try to get the value of AB. The value of AB for this molecule over here is 61. And for this one, it's going to be 62. Yeah. Now you can clearly say, are these position or chain? These are definitely, AB value comes out to be different. And when the AB value comes out to be different, these are going to be chain isomers, right? So these are chain isomers, correct? Yeah. Right? Gaming with the Nafis, types of isomers. Just watch the session from the beginning. You'll get to know. Okay, what about this case? What about this case? Understand. See, just do the numbering right here. This is 1, 2, 3, this is 4, 5, 6, 7, 8. So how many carbon atoms in the parent chain? There are 8. Okay. Is there any substituent starting with carbon? There is no substituent starting with carbon. So value of AB for this molecule is 80. What about this one? Again, it's going to be same. 1, 2, 3, 4, 5, 6, 7, 8. So again, it's going to be 80. Correct? Again, it's going to be 80. Right? So are these going to be position or chain? Are these going to be position or chain? Let me know in the chat box. Position or chain? Absolutely position. The value of AB comes out to be same, right? For both these molecules, position isomers. Okay. What about this one, guys? What about this one? Over here, I need to check. See, first of all, if I ask you how many carbon atoms in the parent chain? 6, right? Is there any substituent starting from carbon? Please do not consider this as carbon. This is chlorine, okay? Yeah? Okay, any substituent starting with carbon? See, this substituent is the chlorine and this substituent is starting from oxygen, okay? So there is no substituent starting from carbon, right? So the value of AB is 60. What about this one? What about this one? First of all, let me give the numbering over here. This is 1, 2, 3, 4, 5, 6. Let's do numbering right here as well. This is 1, this is 2, this is 3, this is 4, this is 5, this is 6, right? So the value of A over here is 6 and substituent starting from carbon is 0. So AB value comes out to be different. Comes out to be same. So are these going to be the chain isomers or the position isomers? What do you think? AB value is same, right? But people, at the same time, just check them out. These are similar molecules. Right here at position number 1, I've got OCH3. Right here at position number 1, OCH3. Correct? At position number 2, we have got chlorine. At position number 2, we have got chlorine. So these are identical actually, okay? These are not any isomers. But be careful with this thing only, okay? These are identical. These are identical, okay? These are not isomers of each other. Yeah? So this is something which you need to take a note of. That's it. Okay, chalo, let's take a few more examples. Look here. In the parent chain, how many carbon atoms? 3. Yeah. How many substituents starting with carbon? 3 substituents starting with carbon. So 33. What about this one? 1, 2, 3, 4. 4 carbon atoms. How many substituents starting from carbon? 2 substituents. So 42, 33. Position or chain? Chain isomers, right? Yeah. Now people, this one. Let's try to do this one. See, this is 1. This carbon number 1, this carbon number 2, this is 3, this is 4. Over here, again, this is 1, this is 2, this is 3, this is 4, this is 5. This is 5. So which isomers these are? See, if you'll have a look on this, what is the value of A over here? How many carbon atoms in the parent chain? 4. Is there any substituent starting with carbon? No. 40 is the value of AB. What about this one? It's 50. Are these chain isomers or position isomers? Check it out. Are these chain or position? What do you think? Are these chain? Guys, their molecular formula is not same. Their molecular formula is not same. We have got 4 carbon atoms in the parent chain. Over here, 5 carbon atoms in the parent chain, right? They are homologous to each other. If you remember in class 10th, you would have studied. These are not identical as well. These are homologous. They differ by CH2 unit. Yeah? These are not isomers, okay? These are non-identical. Right? These are first of all, these are not isomers. So you cannot say these are chain or position. First of all, these are not even isomers. Yeah? These are homologous to each other, if you remember. Right? That means these two, they differ by CH2 unit. Yeah? What about the last question? What about the last question? Let me know its answer. Are these two position or chain? People, again, these are not isomers. These two are not isomers. Their molecular formula is different, right? Their molecular formula is different. Over here, if you check out, we have got only 4 carbon atoms in this one. And over here, we have got total 5 carbon atoms. So first of all, carbon atoms are not same. So molecular formula is not same. So these are not isomers. Again, are the carbon atoms same or different? These are different. Right here we have got additional carbon over here. So molecular formula is different, so they cannot be the isomers. So these are basically homologous to each other. Right? They differ by a CH2 unit, if you remember. Yeah, these are again non-identical. Correct? Correct. Someone is asking, what about the sixth question? Check the sixth. Which one is the sixth one? Eighth or sixth you are telling? Eighth question. Eighth question, you have got total 1, 2, 3, 4, 5, 6. 6 carbon atoms. Right here, again, you have got 6 carbon atoms. Hydrogen also same. Okay? So this thing you need to take in mind. You need to consider. That's it. Question number 8, it's fine. Yeah? Right? Molecular formula in both the ones is same. Right? First, if the molecular formula is same, then only you can define the number AB. Yeah? Perfect. Let's move on, guys. What about these? What do you think? See, first of all, let's give the numbering 1, 2, 3, 4, 5. So how many carbon atoms in the parent chain? 5. How many substituents starting with the carbon? 1 substituent. So the value of AB is 51 for this. What about this one? Just give the numbering 1, 2, 3. For example, this is 4, this is 5. Yeah? Correct? So what about the number of carbon atoms in the parent chain? 5. How many substituents? Only 1 substituent. This is the substituent, 51. So are these chain isomers or position isomers? What do you think? Are these chain isomers or position isomers? What do you think? Let me know fast in the chat box. Are these chain or position? Their AB value is same, right? Their AB value is same, but these are identical, guys. 1 and 2 contains double bond. Add 3, you have got a substituent. Add 3, you have got the substituent, right? So these are identical. These are not isomers, okay? Perfect. Right. Now what about these two? See, you have got the number of carbon atoms in the parent chain as 6, right? Is there any substituent starting from carbon? No, right? What about the number of carbon atoms in the parent chain? 6. 1 substituent starting with the carbon, right? This is the substituent starting with the carbon. So this is 60, this is 61. AB value is different. And if the AB value comes out to be different, we call them as the chain isomers, right? These are chain isomers. Correct? Right? Is that? Let me know in the chat box. Is that? Are these chain isomers? Are these chain isomers? I'm asking you guys, are these chain isomers? Guys, these are not isomers. These are not isomers. Why is that? Because the carbon atoms are different. Molecular formula itself is different, right? Okay? Molecular formula itself is different. So total 6 carbon atoms, total 7 carbon atoms. These cannot be. Okay? What about these two? See, just give the numbering 1, 2, 3, 4, 5, 6. 6 carbon atoms in the parent chain and 1 substituent starting with the carbon. Right? Sorry, 61. 61 is the value of AB. Just a second. 61 is the value of AB. What about this one? 1, 2, 3, 4, 5. 51. 5 carbon atoms in the parent chain, 1 substituent, so 51. 61, 51. So are these going to be position or chain? What do you think? Position or chain? These are, since the value of AB is different for both the ones, so I can clearly say these are chain isomers, yeah? Right? Perfect. Exactly. Wonderful. Okay, with this, I'm sure you can clearly identify now how the chain isomers and the position isomers. Let me know in the chat box if you are clear with the two things, the identification of the isomers, like which one is the position, which one is the chain. Let me know. Let me know fast. And for the ones who have not liked the video yet, please and please do like the video and subscribe to the channel as well. Yeah? Okay. Wonderful, guys. Now, a very simpler one. Functional isomers. This is one more category. Of your structural isomers. So first category was your chain isomer, second was position, third is your functional isomer. Yeah. What are functional isomers? Functional isomers, these are the molecules which have got same molecular formula but different chemical properties. And the different chemical properties will be due to different functional groups. Okay? First of all, let me tell you, the functional isomers are the ones which have got same molecular formula but different chemical properties. And the different chemical properties will be due to different functional groups. Okay? There are certain examples. Example number 1. Carboxylic acids and esters, they make functional isomers. Have a look. If I talk about these two, see, first of all, check the functional group which is attached right here. This is COOH, carboxylic acid. What is the functional group right here? This is RC double bond O, OR, right? Yes. So this is basically carboxylic acid, this is ester, right? This is basically your C double bond OH, this is carboxylic acid, this is ester. This is R, C double bond O, OR, correct? This is ester, this is carboxylic acid, okay? But people first think their molecular formula will be same. Right? See, you can check it out. There are 3 carbon atoms. So this is C3. How many hydrogens? 3, 2, 5, 5, 1, 6. C3, H6. How many oxygen atoms? 2 oxygen atoms, O2. Check over here. How many carbon atoms? 1, 2, 3. 3 carbon atoms. How many hydrogens? 3, 3, 3, 6. 6 hydrogens. How many oxygens? 2 oxygens. So molecular formula everywhere is same, right? In these two molecules, we have got same molecular formula. Molecular formula is same, but their chemical properties will be different. Why? Because of the 2 different functional groups, right? So these are basically functional isomers, which have got different functional groups. So remember, carboxylic acids and esters, they form the functional isomers, right? Okay. Now people, check the second one. What is the molecular formula right here? How many carbon atoms? 1, 2. C2. How many hydrogens? 3 plus 1. 3 to C2H4, O2. This is the molecular formula of this compound. What about this one? Again, we have got 2 carbons. So C2, how many hydrogens? 4 hydrogens. How many oxygens? 2 oxygens. So both the ones again have got same molecular formula, but their functional groups are different. So their chemical properties will be different, right? So over here again we have got carboxylic acid, C double bond OH. Right here again we have got ester, carboxylic acid, ester. What do they make? They make the functional isomers, right? So these are the molecules which have got same molecular formula, but their chemical properties will be different. Why is that? Because of the different functional groups, right? Yes. Exactly. Moving on. This was the first category which you are going to remember. Carboxylic acids, esters, right? Second one. Check it out. Check it out, guys. So what do you think about the first one? What about the, first of all, let me tell you, carboxylic acids and esters. I told you they are going to make what? They are going to form the functional isomers. Now what about this one? See, right here, what do we have? This is C double bond OH. This is basically your carboxylic acid. This is C double bond OH. This is again your carboxylic acid. Yeah. So functional groups are not different. Functional groups right here are same. So should I be calling them as the functional isomers? These are chain isomers, right? Their AB value is different. Right? Their AB value is different. Calculate AB value for this one, calculate AB value for this one. So AB value for both the ones will be different. So these are basically your chain isomers, okay? Yeah? Perfecto. What about the next one? See guys, this is basically, which group this is? This is ester, C double bond O, this is O, this is CH3, right? Okay, this is ester, R, C double bond O, R, correct? This is ester, and over here you have got the carboxylic acid, right? Their molecular formula is same. If you'll calculate, their molecular formula is same, but the functional groups are different. So these are functional isomers, yeah? So remember, carboxylic acids and esters, they form the functional isomers, correct? Now, remember cyanides and isocyanides, they also form the functional isomers, right? Check it out. If you compare the first two, in this one and this one, they have got same molecular formula. But right here, the functional group is cyanide, right here, the functional group is isocyanide. See, in this cyanide, carbon atom is attached with the carbon atom of the parent, this one. Over here, nitrogen is attached with the carbon, right? Over here, carbon is attached with the carbon, right? So this is basically your cyanide. This is what we call as isocyanide. If you check their molecular formula, it's going to be same, but the functional groups are different. Due to the different functional groups, their chemical properties will be different, right? Okay, so these two are functional isomers of each other. Similarly, cyanide, isocyanide, correct? Cyanide, isocyanide. Again, these are going to be functional isomers. Yeah? Their molecular formula will be same, but their but their chemical properties will be different. Why is that? Because of the different different functional groups right here. Correct? Yeah. Rohini, this arrow represents the coordinate bond. Perfect. Moving on. The third category is aldehydes ketones. Aldehydes ketones, they are again going to form the functional isomers. For example, see, check these cases. Check the first one and the second one. These two molecules, they have got same molecular formula if you will calculate. Okay, they have got same molecular formula. Correct? So, they have got same molecular formula, but right here, the functional group is what? Just a second. Just a second, guys. Okay, you take this example. This is not OH right here. Okay, this is H. This is not OH, this is H. Okay, this is H. So first of all, I told you aldehydes and ketones, they are again going to form what? Aldehydes and ketones, they are going to form the functional isomers. Check it out. Okay, see, if you check the first one and the second one, if you check these two molecules, their molecular formula is going to be same, but their functional groups are different. Right here, which functional group is this? This is aldehyde C double bond OH. Which functional group is this? This is R C double bond OR. This is a keto group, right? Yes? Okay. So these are again going to be what? Functional isomers. What about the next one? What about the next one? See, let me know fast. What about the next one? Can you let me know fast? If you check their molecular formula, first of all, molecular formula of both the ones is going to be same. Okay? Molecular formula of both the ones is going to be same. Correct? 6 carbon atoms in total. In total, 6 carbon atoms. Correct? 1 oxygen in both, 1 oxygen in both. Correct? You can count the hydrogen atoms as well. They'll be again same. Right? But this functional group, this is C double bond O. This is R from this side, R from this side. I can say like that. Okay? So this is basically your keto group. This is over here aldehyde group. And we know aldehydes and ketones, they form the functional isomers, right? Their molecular formula is same, but their chemical properties are different. Why the chemical properties are different? Because of the different functional groups. Yeah? Right? Perfect. The next category is alcohols and ethers. Alcohols and ethers, they also form the functional isomers. Check it out. The first one and the second one. First one and the second one. Both the ones have got same molecular formula, but their functional groups are different. Over here it's alcohol, over here it's ether, right? Okay? Alcohols and ethers, what do they form? They form the functional isomers as well. Okay? So check it out. This is the ether over here. This is the alcohol over here. Correct? They have got the same molecular formula, but their chemical properties will be different due to different functional groups. So again, they are what? Again, they are your functional isomers. Yeah? Next category, thiols and thioethers. Thiols and thioethers, they are again going to form what? They are again going to form the functional isomers. Check it out. Their molecular formula is same. See, this is your thiol, this is thioether. This is thiol, this is thioether, right? Check their molecular formula. Their molecular formula will be same, but functional groups are different. Over here, SH is the functional group, thiol is the functional group. Over here, thioether is the functional group, right? So their chemical properties will be different. No doubt their molecular formula will be same, but their chemical properties will be different due to different functional groups right here attached. Yeah? Okay? Alcohols and phenols. Alcohols and phenols, they are again going to form what? They are again going to form the functional isomers. Check it out. See, first of all, whenever you see OH group directly attached with the benzene ring, whenever you see OH group directly attached with the benzene ring, that means this is the type of phenol, okay? Right? This is the normal alcohol. This is the normal alcohol, correct? This is the normal alcohol. This OH is not directly attached with the benzene ring, okay? If you check their molecular formula will be different, okay? Their molecular formula will be different, right? But these are going to be their chemical properties. Sorry, their molecular formula is going to be same, but their chemical properties are going to be different, right? Okay. Their molecular formula, if you'll check, it's going to be same, but their chemical properties will be different because these are alcohols and phenols. As I told you, alcohols, phenols, they form what? Functional isomers, right? Similarly, if I talk about amines, if I talk about primary, secondary, and tertiary amines, primary amine, secondary amine, tertiary amine, right? Definitely, they'll have the same molecular formula. These molecules right here, if you check, they will be having same molecular formula, right? But their chemical properties will be different. Why? Because this is primary amine, this is secondary one, this is the tertiary one, yeah? So these are again your primary, secondary, and tertiary amines right here. These are again going to be your functional isomers, correct? So with this, our three types are done and dusted till now. One was, if you remember, we started with something called as isomers. Let me give the brief summary of what all things we discussed. We talked about something called as isomers, right? Okay, and we classified isomers into two types generally. One is structural, one is stereo. Yeah, in the structural one, first we talked about something called as chain isomer. Then we talked about the position isomer. And at the end, we talked about the functional isomer. These are the three isomers which we discussed till now. And the best part was how to check which one is chain isomer, which one is position isomer. If the number AB comes out be same for two molecules, it's called as, we call those molecules as the position isomers. Okay, and if the number AB comes out to be different, we call the isomers as the chain isomers. Only this thing you need to remember, you're done, yeah? Okay. So I'm sure this clear till here, right? Okay, so for the ones who are new to the channel, just it will take me 2 minutes to give the quick introduction of the NEET crash course, which we are starting on the Vedantu platform, the actual Vedantu platform, apart from the YouTube sessions, right? So first of all, this crash course is for the students who are going to write NEET in 2021, right? In this crash course, Exactly, Karthik, exactly. In this crash course, first of all, we are going to cover your entire NEET syllabus as per the new pattern, right? Okay. In this NEET crash course, which is going to be on the actual Vedantu platform, apart from the YouTube sessions, we are going to cover your whole syllabus, right? And the syllabus is going to get covered in 120 sessions in total, right? No need to worry about the test series, no need to worry about the assignments, okay? Test series, everything will be included right here, okay? And people at the same time, apart from the syllabus completion sessions, there will be some extra sessions regarding the time management, okay? Regarding the tips and tricks by means of which you can solve the questions in lesser time, yeah? Okay, and it's, as I always say, it's a two-way learning interactive platform wherein you can ask your doubts anytime to master teachers, right? So people, this is the last option for you guys to get enrolled in this one. Trust me, you are going to get benefited if you are going to get enrolled in this one, because I have seen people getting enrolled in this crash course, shooting up their performance. Trust me on that. And because you guys are personally getting trained by the teachers of your choice, number one, in your physics, chemistry, as well as biology. So do get enrolled in this one. It is Yuvashri. What you get the study material in this as well. That's what we call as Tattva material. Tattva material is considered as one of the best material in the entire country. Trust me on that, okay? You can Google it as well, okay? Perfect. So people do get enrolled in this one, and how to get enrolled? Just you need to download the Vedantu app. After downloading the Vedantu app, click on the Vedantu app. After clicking, just click on NEET Crash Course, and after clicking on NEET Crash Course, use this coupon code. This is my coupon code, Wassim Sir, WSNEET. Okay, this is my coupon code. If you are using this coupon code, I'll be training you personally, and at the same time, you'll be getting 30% off as well. Yeah? Right? Okay, so let me tell you, the next batch is starting on 17th of May. This is probably going to be the last batch of the NEET 2021 crash course. Most probably it's going to be the last batch of the NEET 2021 crash course. So do get enrolled in this before it gets filled. Okay, you can enroll in this by other way as well. That is, you just need to click on the crash course link, which is there in the description box of the video. Click on the link, enroll, and let's kill it together, right? Yes, Shrishti, I'm from Kashmir. Yes. Okay, for the ones who are going to write the NEET in 2022, again, for you guys, we have started the program, the actual classroom, okay? And the next batch is starting on 17th of May. For you guys, you can use the coupon code WSPRO if you want to join in, okay? The link is there in the description box of the video, right? Okay, and if you are using this coupon code, you are getting 13% off right here. Yeah? Perfect. So one more link is there in the description box. That's for the Telegram. Do click on the link, get added to the Telegram group, stay updated about the classes. And at the end, for the ones who have not liked the video yet, please do like the video, share the video with your friends, and subscribe to the channel. And do not forget to hit the bell icon, okay? It was nice meeting you. I'll see you guys tomorrow, okay? At the same time, right? Till then, you take care. Bye-bye. God bless you all and love you all. Take care, guys. Bye. Take care. Mohammad Irfan, coupon code for crash course is WSNEET, and coupon code for the 12th NEET 2022 students, that's WSNEET. You'll be getting the coupon code in the description box of the video. Thank you, Leo Jax. Thank you.